This structure assembling itself is what happens behind the scenes on over 21 million websites. Elementor isn't just a theme, it functions as a heavy, powerful front-end web application running inside WordPress. Most static WordPress themes require very little server effort to display a page. They load a few files and the process is finished. But when the server is underpowered, the page builder starts to fail. The editor freezes mid-save, templates refuse to import, or the screen simply goes white with a server error. Designers often look for bugs in the Elementor plugin, assuming their unlimited shared hosting plan should handle the load without an issue. This chart shows why generic plans fail. A standard theme load is a single event, but a 5-minute Elementor session fires massive AJAX requests that bypass full-page caching. Every dragged widget or updated setting forces the server to do fresh, dynamic work. Saving a few dollars on generic hosting leads to workflow lag and unpredictable site instability. Smooth Elementor performance begins with an audit of the server infrastructure sitting underneath the plugin. This 5-factor infrastructure scorecard determines if a host can handle the load. Factor 1 is your PHP memory limit. Elementor requires a 256 megabyte memory limit as a baseline. This is the minimum amount of RAM needed to load the widget registry and parse your page structure. When memory is too low, complex operations fail. You try to import a large template, but the server runs out of RAM and stops. Adding WooCommerce or translation plugins like WPML increases this footprint. These sites often require 512 or 768 megabytes to prevent the editor from crashing during a checkout page build. Optimized hosts allow you to raise these limits by selecting PHP 8.3 or 8.4 in your control panel, giving your site breathing room instantly. Factor 2 is the execution model. If your editor freezes when you save, you're likely hitting the AJAX wall on a standard PHP-FPM setup. In this model, the server drops and restarts the connection for every single AJAX request. During an active design session, this creates a bottleneck that results in 4 to 8 seconds of lag. Compare that to a persistent worker model like LiteSpeed LSAPI. Here, the connection remains open, allowing data to pass through without the restart overhead. Because these workers stay alive between requests, your rapid-fire saves and widget updates are processed the exact moment you click. A high memory limit is useless if your server has to rebuild its connection to PHP every time you move a widget. Factor 3 is caching architecture. Page builders need a specific type of cache to deliver fast load times to your visitors. This shows how a standard cache plugin works. The visitor's request still has to wake up the PHP stack and bootstrap WordPress before the plugin can even check for a cached page. Those extra steps create latency. Visitors usually wait 80 to 150 milliseconds for the server to react, even when the page is already cached. Server-level caching, like LSCache, intercepts the request at the outermost layer. It returns the static HTML without ever touching PHP or WordPress. This reduces the response time to between 10 and 30 milliseconds. This system also helps the designer. LSCache automatically identifies Elementor editor URLs and keeps them uncached, so you always see your live changes while your visitors get the high-speed version. High visitor speeds require this web server integration. A standard plugin cannot fix a slow hosting foundation. The fourth factor is account isolation. This is often the biggest reason Elementor sites slow down on shared hosting. On basic shared hosting, everyone draws from the same pool. If a neighboring site runs a big sale and exhausts the shared PHP workers, your site stops responding. Factor 4, resource isolation through CloudLinux LVE, fixes this. Every account is placed into its own tank with a guaranteed amount of CPU and RAM. Even if a neighbor hits their limit, the impact is contained. Your resources remain stable, ensuring your editor stays responsive no matter what else is happening on the server. Factor 5 is file system isolation, which moves the focus from performance to security. A system called CacheFS jails your WordPress files in a private virtual environment. This prevents a compromised account on the same server from reaching into your Elementor template library. Choosing unisolated hosting surrenders complete control of your uptime and security to random strangers living on your exact same server. Optimization happens at the server level. You must match your infrastructure to the specific complexity of your build. For basic sites, start by checking memory. Setting your host to PHP 8.4 with a 256 megabyte limit is a zero-cost way to stabilize simple builds. If you've increased memory and the editor still crashes during saves, your host's execution model is likely the bottleneck. E-commerce requirements are higher. Elementor Pro with WooCommerce needs a 512 megabyte minimum and a persistent LSAPI model for dynamic database requests. Building a store on a standard PHP-FPM setup will throttle checkouts and cause abandoned carts. Agencies and freelancers require CloudLinux LVE and CacheFS file isolation. This keeps client sites separated and prevents one site's traffic spike from affecting the entire portfolio. Putting all of your client sites into an unisolated shared hosting pool creates a massive single point of failure for your entire business. Ignore the unlimited marketing claims. Use this 5-factor checklist to ensure your server actually supports the way Elementor was designed to build.